First of all, thanks for taking the time to be here. I'm going to talk for how to develop for enterprise blockchain. So I'm going to focus on the enterprise side. It's kind of a little bit away from the public blockchains regarding adoption and regarding the models and the benefits that these technologies bring to the ecosystem. So it has different goals behind the scenes. It's kind of it's a similar technology. I will be focused on Hyperledger Fabric specifically, and I will show you how to leverage some tools that we have been building for you to create some business around this. Yeah, I think the internet's not going to work, so maybe we can try it. I have it, but it's not connecting. No, it's not showing me the Wi-Fi. Okay, there you go. Now we can start actually. So yeah, again, as I was telling you, I'm going to talk about business uses of blockchain, and I will focus on the developer area. I assume that all of you are technical and that you are familiar with developer tools and so on. So I will just go through some high-level details about blockchain. But if you need more details or clarification, just tell me. Just to be in context, blockchain was released, as you know, 10 years ago. The enterprise blockchain that is sometimes called private or permissioned blockchain has 4 years since Hyperledger Fabric was released, around the time that Ethereum was released as well. So to be in context, that's a lot of time. I mean, when mobile devices were released, it didn't took much time after we started getting the right developer tools for anybody to create applications. Right now a JavaScript developer can create an application for a mobile as simple as they create for the web, sometimes even for the desktop as well. But with blockchain, this has been kind of weird that there has been this big amount of time, but you still need an expert on blockchain to create a smart contract system. That is something that is weird regarding the maturity of technologies. For example, with databases, it is the same. Regarding databases, you don't have to be a low-level expert in databases to use a database, but in blockchain you have to. Otherwise, you cannot build things. So to put this in perspective, this is one of the reasons why we, as the presenter was saying, I come from WorldSibu, why we are focused on creating development tools and tools for technical people to create smart contract systems in an easier way. So again, the 4 years term is since Hyperledger, the Hyperledger project, which is from the Linux Foundation, was released. So different from the public side of blockchain, in which we usually look for decentralization and removing intermediaries and making things a little bit easier without depending on third parties. In the business side of blockchain, what we are looking for is to reduce business frictions. And business frictions is a term that we usually don't ask much because, for example, we are kind of used to some inefficiencies in the business side. For example, we go to make something with the government, like, I don't know, asking for a document or something like that, and we are used to that is slow, that is a really chunky process, and we're kind of used to that. For example, if we are buying a car, we are used to do things like go to talk to the insurance company and then go to talk to the bank and talking with the dealer as well. We are kind of used to those frictions in the business side. But that is one of the reasons why startups getting into the blockchain, into the enterprise side, usually are so different from the current setups. It's not necessarily about the technology. It's not necessarily that they know better than the big incumbents and the companies that are already established in the enterprise side. It's that they are lean. They are looking for less frictions. They work around problems to avoid these issues. So usually in the business side, when we talk about the startups getting in there, we refer to things like lean, like fintech, like regtech, insurtech, and so on. So what they are looking for usually is to create efficiencies and to reduce business friction. So that is the main goal of blockchain in the enterprise, and it is important that we separate things from the public and the private side, because even though, again, as the technology is kind of similar, the goals that they are looking for are different. So let's say, for example, this is just a quick overview before we get into the technical details, because I usually find myself in conversations in which people think that a permission blockchain or an enterprise blockchain is a private blockchain. It's something that a bank has for itself, and it is not like that. It's something different, and I will try to make it clear for you. So let's imagine that we want to buy a car. So we are the guy in the middle with a lot of doubts and a really long process of months usually. This happens the same when you are buying a house, for example. So you usually have banks, you have government, you have the car dealer, you have the insurance companies, and a lot of other players that don't talk to each other, right? Usually, from a technical perspective, they have all of them have these separate databases, and we usually refer to the bank's database or the insurer database. We don't talk about the business entity, which is a car. A car is made up of information segregated and separated in different databases, in different premises, in different companies. So when we wanna, buy a car again, you have to talk with one and to the other, talk to the other, and so on. And we think that this is normal. We're usually, we just say things like, yeah, that happens. And sometimes when we get setups like this, there's a big opportunity for fraud. Because if the information is always separate and nobody can get a single source of the truth, people can take advantage of those inefficiencies. And they can, do things, for example, in the insurance area. It is common that, at least in Costa Rica, you can you can insure your car in 3 insurance companies at the same time. You crash your car, and you go and you ask for reimbursement of the money for the 3 insurance companies. And that happens because insurance companies don't talk to each other. They have separate databases, even though that information should be shared somehow. Sometimes the government gets in the middle and they try to say things like, yeah, give me the information and I give some value back to you. It's kind of the same like Equifax and companies like that, because they are trying to avoid this mess. This is something really that doesn't make sense. Because from the business perspective, usually when you are looking to grow a business or you're looking to expand a business, you're looking for partners, you're looking for customers, you're looking for more relationships. In the technical perspective, in the enterprise side, let's say banks, insurance, supply chain companies, you are doing the opposite from the technology perspective. You're thinking on how can I protect my database? How can I avoid people getting my data? Usually those are not in sync, and that is one of the reasons for the business frictions that I was talking about before. So usually, all of you know, this is the status quo of today. If you don't use a blockchain, for example, in an enterprise setup, you have the first scenario in which you have a third party in the middle, like Equifax. This is what some people call honeypots, data honeypots, because they are really attractive sources of data that somebody can hack. And that's what happens to Equifax. That's the reason why they get hacked every week, right? Everybody gives the data to them, and then they give back some information. Governments sometimes play that role as well, and we depend on them. We depend on the bureaucracy, and we depend on all the not so great things that they bring to the table. And this is really normal. For example, here in Costa Rica, we have from the central bank, we have Simpe, which is this exchange between banks' money system. It's kind of unique in the world, what we have here in Costa Rica with Simpe. It makes things easier, but we depend completely on the central bank. So if they do something like, I don't know, they get hacked or something like that's the only source of data. And they do that because, as you all know, money cannot be created out of nothing, so we create these business rules and we create all these regulations and all of these things in order for multiple parties to communicate with data that is not from them, that they don't control completely. They cannot create or they cannot modify it just like that. And on the other side, we have the other setup, which is actually the most common. Usually people say that blockchain is going to be, they still say it's going to, people usually refer to like IBM is going to transform or R3 is going to transform. It's usually in the future. I will try to get it into that topic later, but from the theoretical perspective, it kind of makes sense that, for example, supply chains use blockchain. Because that's what happens, like in the image on the right, you have to communicate one-on-one with different technologies, sometimes with legacy systems. That is a reality. Before founding WorldSibu, I used to work with a lot of enterprise companies like banks, and you really find things that you don't believe, like somebody has a system in COBOL and the other one has in C# and they try to communicate, and sometimes they don't even have JSON or XML to communicate. They use like these weird formats in which you concatenate characters and things, really crazy things. So it's like everybody's talking in different languages and they're trying to communicate. But even if we solve this in this way, we still have a lot of unconclusive designs that usually blockchain is going to solve. So this is for me the two main reasons why blockchain in the enterprise makes sense. Aside from the money perspective, from the transaction, the monetary transactions, the first one is that it is so hard to get the actual truth of the data that people just stop doing it, because every company has their own databases with their own records, even if this data should be crossed in some way. In Costa Rica, for example, actually in Central America, it happens that around 15% of the imports and exports that we get through Central America goes to fraud, because all the databases of every participant in the export and import process are separated. So people take advantage of that, asymmetries in the information. That happens in a lot of industries as well. I was giving you before an example in insurance as well, but that is really common. So imagine that you have to actually get the information of, I don't know how I got my cell phone here in Costa Rica. That's probably from outside. You can audit Apple or Samsung and they can give you some information regarding how the cell phone was made. But for example, here in Costa Rica, how can I know who imported this, who transported this? There's no way to get that information. So people take advantage of that, and that is really hurting the economy. And the second one, which is also a big problem, is the business friction that we were talking about. It's just a business stopper, right? So when you get business stoppers, artificial business stoppers, due to a design issue, because this is just a design issue, we have designed the world in the wrong way. So we can solve this. Those are things that doesn't make sense. I still think, if we continue to think in this isolated way, in this is an island of data, this is another island of data, we won't ever get to a real digital world. Exchange of information in the enterprise should be smooth, and today it is not. That is why in the enterprise blockchain makes sense. So obviously when you add blockchain, you all have seen this diagram in which you see every participant with their nodes, and they connect and they exchange data. So instead of going to one or the other, you have all the information in the same place. And again, I am making these clarifications because usually when I talk to people that come from the public side of blockchain, if you may, they usually have this erroneous idea that sometimes companies like IBM, Microsoft, or Amazon gives you, that is that a private blockchain is something that is in a centralized setup, or that it is controlled by one party. That is not true. The permissioned side of blockchain, or the enterprise side of blockchain, is what is called permission. So it means that businesses have different contexts and have different governance models. I saw like 2 years ago an interesting talk that was given Vitalik, that he was talking about enterprise blockchain networks, and he was saying something that I don't usually hear that much. That is that in the enterprise side of blockchain, there are also incentives for transparency, incentives for quality, because if you don't do things the right way, you have legal bindings to the country or to your legal setup in which you can get penalized. So it's not always about crypto economy to create incentives, you can have other kinds of incentives. So in the enterprise side, you cannot ask a bank to just get to a network in which everything is anonymous. Nobody's gonna accept that. So that is the reason I believe that why sometimes people think like these banks are going to be removed and replaced by blockchain or things like that. But it's usually unviable to ask companies to get into the full-blown public side of blockchain because they need different models of governance. Another reason on why an enterprise blockchain makes sense, and this is not one or the other, I will talk about hybrid approaches as well, but another important thing that we have seen by talking and working with enterprises is that when they get into the technical details and they see that public blockchain, for example, may stop working tomorrow because of bad management, about open source management, or because people think that now what is cool is another network, so it just people start adding nodes and things like that. That really scares people. That really scares the enterprise. That they don't have control over the infrastructure. And just to wrap up this part, enterprise blockchains needs accountability, confidentiality, and control, and that is something that is hard to get into public setups. So we have found these statistics regarding about the blockchain area. In the enterprise side, as of the last year, 68% of the revenue made by services in the enterprise side, like selling services to banks or to insurance companies or supply chain companies, 68% of the revenue goes to just 3 companies: Microsoft, IBM, and Accenture. These 3 companies are getting from the worldwide revenue made from services in blockchain that amount. And there is one reason. Different from the public side, in which everything is open source, and people are willing to give their source code for people to continue build on top of. These companies are not. So it is really complicated and expensive for a startup or for a regular company to build a blockchain project. And the statistics are around this. For a company to actually get to know something like Solidity and actually be in a mature state to actually deliver a project, or something like developing Golang smart contracts for Hyper Fabric, it takes around 3 months. For a developer to say, I feel ready, I can deliver something that actually goes to production. And that is the first problem. And the second problem is that it takes around 6 months for a company that has nothing to do with infrastructure to learn all the infrastructure matters and build it so that they can deliver a project. In the enterprise side, you usually don't have this ready computer, worldwide computer, like in Ethereum or all of these blockchains. You have to build everything from scratch. You have to create the servers, you have to put them somewhere, you have to connect them and do a lot of things. So when we have found that some developers, they go through the learning curve of 3 months. So they now are ready to deploy their smart contracts. And when they try to go to production, they don't have an infrastructure to deploy. It has to reside somewhere. And the infrastructure cannot be, it doesn't make sense if it is centralized. And the way you do today infrastructure in an easy and fast way is centralizing it. So it doesn't make sense, actually. So if you try to decentralize an enterprise infrastructure, it takes around 6 to 8 months. Those are the main problems that we are tackling right now. Just as a reference, I know all of you are technical, but this is a simple architecture on how an enterprise blockchain looks like. An enterprise blockchain system or smart contract system. You usually have on top of the users and the bots that are going to communicate, like IoT bots and the end users. Usually they have 2 ways to communicate with the blockchain. They can use a regular system. In regular systems, for example, let's say that you implement a software with a bank. The bank is not going to give wallets to every single employee. It doesn't make sense. They already have what is called a PKI, which is this infrastructure for certificates that they have. They usually don't give wallets to their own users, right? They use the existing system and somehow they connect this to blockchain. So in the first way, which is this one that is in here, you have the regular user interfaces like CRMs and ERPs, and they communicate to the decentralized APIs. So the wallets or the certificates are actually in here. The user does not have access to these certificates, because in an enterprise setup, you are not identifying individuals. You are identifying parties like organizations or companies, those are the ones that need the certificates. That usually has been happening for 20 years in the enterprise side. But in case that you need to give a customer direct access to the blockchain, like giving a wallet or a certificate, you create decentralized apps that the customers can communicate directly to the same tools that they use for public blockchains. And sometimes you have services that they come from IoT devices or things like that. At the end, on the lower level, you have the rest of the tools that actually provide value to a blockchain, to a smart contract system. The thing is, usually when people are starting building smart contract systems, they kind of over-focus on the smart contract part and in the blockchain part, but in a business setup, that's just a small part. First of all, you don't put all the data in the blockchain. That doesn't make sense at all in the enterprise setup. You just put some specific data that is going to create links, that is going to make things work. For example, regulate business relationships, or creating some historical data or things like that. So you need all of this ecosystem of different off-chain services that you communicate and somehow coordinate with on-chain services. So you have databases, you have data analytics, you have oracles, and so on. So I will focus on the demo that I brought to you in this part, in the blockchain area, in which this is where the smart contracts reside. So the smart contracts is at the end just code that is going to run in a specific context on the servers. But you also, when you're building a smart contract, you need all of this. And this is important because, again, we have found a lot of people that create the smart contracts and they don't know how to make money out of this. Because even in the enterprise side, you create a source code, right? And you deploy it to an enterprise network. It has to be open. You cannot protect that code. You cannot just compile this or encrypt the code, because as is in the public side, in the private side of blockchain or permissioned side of blockchain, all the participants need to be aware of the data and of the rules, so they have to review the source code. So I have found that people get to us and say, yeah, I created a smart contract, when I try to sell, they get the source code, so why would they still pay, right? If they have all the source code. So you have to create all this ecosystem for a smart contract system in the enterprise side to make sense. So yeah, let's get into the actual technical part. That was the 5-minute introduction that took 20. I'm going to focus on the software developers that create smart contracts. This is another common confusion, that people think that a blockchain developer is the guy that creates smart contracts, and this is usually the other way around. The blockchain developers are like the core developers, like the Bitcoin developers or Ethereum developers, and the smart contract developers are the ones that drive the adoption of blockchain in real use cases. These are people that usually are not experts on cryptography, and they don't have to. Again, just like databases. I can have like a nutrition company, I can create an app, and I can go and sell it, and I don't have to be an expert in databases to use databases. So usually these guys have different priorities. They are more focused on the business side, and I'm going to talk about them. So I talk really quick about us in WorldSibu. What we do is we build tools and platforms for the enterprise side. We have like these big areas. The first one is what is called the Convector suite. As I was telling you before, part of our vision is to solve the problems of companies building smart contract systems, right? So it's, as I was telling you, it's really a long process for most of the people. There are a lot of high entrance barriers for them. So we identify two big sections in which there are the most problems while building smart contract systems. The first one is the builders, the ones that are coding everything from scratch, and the ones that don't want to code everything from scratch, but that they want to integrate blockchain systems or smart contract systems with their existing software. So this is the first part, and I'm going to talk about each one of them. And on the other side is the deploy, the final goal. When you create infrastructure and you deploy the smart contract and people actually start using it. So I will be focused more on the open source side. I will show you some code, and I will walk you through around the tools. But I will also show you a little bit about Telus and about Forma, so just for you to give you an overview of what we do. So Convector is a suite of tools. Sometimes people compare this to Truffle in some way, and sometimes to other tools like sometimes some libraries from Zeppelin, because you get that in the public setups. You can get those tools for free. In the enterprise setup, you don't get those tools. It's really hard for people to start, and I will show you a few details. Convector is a smart contract engine. It's built on TypeScript, so if you know JavaScript, you can build smart contracts really easily. And Hurley is a development environment manager. It's the one that looks like and feels like Truffle, kind of. The Convector suite has over 25,000 downloads by now. We released this 5 months ago, and we have users from India, United States, Canada, South America, and some other parts of the world. So again, I'm going to focus on this open source setup, and then I will show you a little bit of Telus and Forma. Hyperledger Fabric is the first blockchain project that raised their hand and said, we are ready for production usage amongst all the enterprise blockchain frameworks. Fabric is the first framework inside of the Hyperledger project. Hyperledger is an umbrella of projects. Fabric is one blockchain framework, so it's not a blockchain itself. You build blockchain networks with Fabric. And this is an example of a Golang smart contract. I know you cannot see, and that is part of what is interesting about this. All of this that you see on the right is just to query an array of data. So what is happening there? First of all, it's Golang, and not a lot of people really love Golang. There are just a few people. I don't really like it personally. But you have to do these really low-level things. As you can see on the right, you have to do things like managing buffers, like extracting arrays of bytes. You have to transform data. You have to do a lot of manual things. So it makes sense that it takes you 3 months to build code if you're doing this, right? And if you can see, for example, the properties, this is a structure like a model on the left that says car. There's no really way to build, to blind this code. It's really a manual process. Convector is a tool to make this easier, to make this more robust. This is an example of a Convector smart contract. We separated concepts different from the Golang smart contracts, for example, in which everything is in a single file. We created this model controller pattern in which you think of the models in one way and you think of the controllers in another way. The controllers are the business logic and the models are the business structures. So when you are building something, what you have to do is first do this model. In this case, you just need to define the properties like in any JavaScript class. As you can see, this is no more than JavaScript. You define these decorators. Decorators do some heavy lifting for you. For example, there's some manual work that you have to do when you validate things. Let's say that you receive a transaction and you have to see that some fields are required, that are included in the transaction, in the function that is receiving the parameters. You usually have to create an if statement and you have to check everything manually. In here you add decorators and you just focus on the business structure. In this case, it contains something that's called make, model, color, and owner. This is from an example from the Hyperledger project that we ported to Convector. And you start coding, again, more focused on the business side. And this is an example of the controller. I showed you before this is just one function. This is one function to get all the registries from the database, from the ledger, right? Imagine this multiplied by 4 or 5, which is every function that this smart contract has, and all of that can fit in this small class that we have on the right. So what is happening in there is that we have these functions, we mark them with decorators, like in this case invocable. It exposes them to the blockchain. So Convector is going to do this. Convector is not creating extra layers on top of Fabric, it's working with the tools that Fabric provides. So instead of you receiving an array of parameters, with Convector what you do is you send a JSON object and it's going to map it out to all these low-level structures. So you actually work like if this was a JSON, but it is actually not a JSON. Behind the scenes, it is not. And we can do some interesting things. For example, for me to get a data, a registry, I can do car get one, or car get all, or car that's safe. It is telling me my model is going to connect to what is called the stop in Fabric, which is the ledger, and it's going to get data or send data. So you can see that there's a big difference between these two kind of codes. And if you don't want to go through learning Golang and you already know JavaScript, you can start, for example, tomorrow. You just have to run this command that is conv new and the name of your project, the parameter C, which is for the chain code. In Hyper-J Fabric, smart contracts are called chain code because it's actually code that runs in the chain. It's not really smart nor a contract, so people change the definition of this. But this is a tool that Convector brings, and you just have to type that, and you have all the bootstrap of the project that I will show you in a few minutes. And another part that is important as well, as I was telling you, and smart contract system is not just the smart contract. It is also the backend services on top of that. It's also the front-end services. It's also the APIs and all the things that you built around this. This is an Express code. This is an Node.js backend. What we can do with Convector is that you can import your source code from the smart contracts, from chain codes, and you can reuse the same code base in your backend. So what you are doing here, for example, when you type query all or create or change owner, which are functions coming from your smart contract, instead of going to the blockchain, it's in a upper level. It's going to go through the HTTP protocol, and it's going to call the chain code, the peers, the nodes, and it's going to then call the smart contract. So you can take the same code that you created for the smart contract and you can replicate and reuse it in different layers, like front end and back end and so on. So you don't have to worry about making mistakes like some typos or things like that. So I was showing you this code runs in the blockchain. This code runs in Node.js, but it is the same code base. You don't have to retype everything. You don't have to recreate everything. And the second open source tool that we have is Hurley. Hurley is a development environment. Again, these files, you cannot see them well, and I don't want you to see them. I don't want you to see these complications. What we want is that people can do something like this, and they can create a new blockchain network, they can remove their development environment, they can install a smart contract, they can upgrade a smart contract, and they can invoke a transaction. Instead of going through all of these files are what are called config transactions, crypto configs, Docker Compose files to start your servers, scripts just to make simple configuration tasks. Today, if you don't use Hurley for Hyper-J Fabric, you have to learn all the settings that are on these files. Usually are YAML files, which are not really friendly for people, and you have to be really an expert in that specific blockchain technology. So that is one of the reasons why if people get into Ethereum, they don't move away from Ethereum. It's hard for somebody from Ethereum to go to EOS or to go to Hyper-J Fabric as well the other way around. Because you have to be really an expert on all level things. What we are creating with Hurley and with Convector is this higher level of abstraction, because what we expect that Convector is going to be agnostic. So that this is not going to be specific just to Hyper-J Fabric, but that the source code can also be used for Soulfood, which is also from the Hyper-J Fabric, for the Hyper-J project, in Quorum or Ethereum, as well as other blockchain networks and blockchain frameworks. So again, it comes as easy as this, that we can start creating things instead of going through all these configuration files. And again, if you have worked with something like Truffle, probably for you this really makes sense. It's like, yeah, you should have had that before, but we didn't. In the enterprise side, we don't get those tools. And it again gets reflected on the centralization of services that we get in the enterprise side. For an industry that has 5 years, 4 or 5 years of maturity, to have just 3 companies making 68% of the revenue, there's something wrong in there. Companies are not incentivized to actually get into these businesses and compete with these big players. But with these tools, we have found companies in India or in South America that are starting to create their smart contract systems. They can get started in 10 minutes instead of months. I will show you this in actually how this works. So let's go to the code to see if this demonstration works. Usually they don't. Any questions so far? No? Okay. So I'm going to work with this that is called a FAFCAR example. FAFCAR is this really simple business or smart contract that helps you like get around the basic concepts like the models and transactions and updating data and inserting data. This is actually from a post that I made in HackerNoon, so I can add the link later if they are going to share the presentations with you and you can read all the explanation. But what it has is a Convector smart contract project created for us. So what I did before coming here, because I knew we may have problems with the internet, was I installed Hurley. You can install like this. If you already have NPM in your computer, it runs on Node 8, and you also need Docker for you to create, the blockchain, like the servers and so on. You just have to install Hurley like this, and you have to install Convector CLI like this, and there you go. You're ready to go. You don't have to do anything else. You don't have to download Hyperledger. You don't have to compile the source code of Hyperledger or anything like that. So what you can do in here is something like, I can do this, and I can call this this example. I can do conv new FAFCAR, and I can create a default smart contract that is going to be car. So I click this, and it bootstraps the project for me. As you can see, it creates all the necessary files. So if I go in here, for example, I can get into this. It's like a generator, like what you have in Node, like Geoman and so on. We try to make it feel like the same setup. Getting open the actual folder. Let's see. Here we go, and this one. So yeah, let me open this folder to show you the basic structure of a project. This is the one that was created for us. And here, this is the basic structure of a Convector project. So what it has is the smart contract in here. We use something that is called Lerna. Lerna for the JavaScript developers is a way to manage packages so that we can have multiple separate projects that can import to each other, so we can reuse code. So if we build, for example, a model, we can reuse the same class in other projects, so it's really handy. So we told the tool to create a smart contract called car in this, and on the SRC folder we have this basic controller and we have this basic model. So there you go, you are ready to go. With this, you have the basic files for a smart contract in here, so you don't have to create everything from scratch. But also, it is integrated with Hurley, so you can actually start a blockchain project from scratch with this source code. So it includes this package JSON with these tasks, in which if you call env restart or you call env clean, you are actually calling Hurley, and it's going to set up everything for you. So as you could see, I just typed this small line and I created this bootstrap folder. What I would have to do is to go here and type npm I to install all the dependencies of the project, like the Convector dependencies. Since I don't have an internet connection, I brought everything downloaded for you so that we don't have to wait in here. So I have this project. This already has the node modules downloaded for me. So what do you usually want to do? When you are starting to develop, you want to have somewhere to test, like this blockchain network, and you usually want to test your code really quickly. So in here, we have this, let me see, here's the folder. We have this README file that is going to give you all the instructions on what you need to do. So you already have the basic source code. What it's telling you is, if you want to start your blockchain network, let me see, where is this? There you go. Okay, so yeah, it tells you have to install the dependencies, you have to run curl new, which is the one that is going to start the blockchain for you, and then you just run curl install, and you tell the name of the smart contract, and it gets installed. So it gets a lot easier if you just go to the folder project. And sorry that I'm switching to one of the other. It's because I don't have the dependencies on this one that I just created. So you can do something like npm, and you can see the tasks from here. Run env restart. So what is this going to do? It's going to check if I have the binaries downloaded from Hyperledger Fabric. It's going to check if I have an existing Hyperledger Fabric blockchain network working, and it's going to check if I have the requirements like Docker and so on for me to connect and to set up the blockchain. So this first task is just starting a blockchain network for me, nothing else, right? My smart contract is still just code. So it's actually checking on the internet if I have these Docker images. As you can see, what it is saying is I'm checking if you have everything that you need. If you run curl new, it's going to remove everything that you have, and it's going to create a blockchain for you from scratch. This is important because we found that if you are developing in a non-immutable setup, for example, like that you get a lot of changes, like somebody adds a new node or something like that, things get messy. So it's better if you just remove the whole environment and you recreate it because it's your development setup, so it's not really a problem. So there you go. It's telling you I just created all of these configuration files. As you remember in the presentation, all of these YAML files, you don't have to go through them. If you want, you can, because it generates everything for you so that you can actually check what has been created for you. It's telling me I also created some users. Users are like wallets in like similar to public blockchains, and that's it. Like this, I have set up blockchain with this information. This was self-generated for me. I can do interesting things like I can tell I want 10 companies instead of 2, which is the default. So if I go in here and I do Docker PS, like this, there are my blockchain setup. I don't think this cannot be really easy to read from behind, but it is telling me you have this Hyperledger Fabric image, you have these peers, you have this certificate authority, and so on. So just like that, I already have a development environment to test my code. So what I can do is actually deploy my code, to test this. I brought the smart contract ready for you because I didn't want it to get into the details. So I have some extra properties that I was showing you in the image. The make, the model, the color. This is for a car factory emulation. So we are going to create cars, and the cars are going to have owners. So I already have some functions like the init ledger that is going to create some mock data for me so that I can test things. I can do things like queries, like create things and change owners. So let's say that we finish creating our smart contract. So how can you test this? How can you deploy this to your development blockchain? So again, if we go to the package JSON, we can see some tasks in here. If we run this cc start, it's going to install everything on that blockchain network that I have. So I can come in here and I can do npm run cc start, and I have to give the name of the chain code that I provided of the smart contract. When I was creating this project, I told this that my smart contract was going to be called car. So I'm going to continue with that standard. So I run cc start car. And what this is going to do is it's going to compile my code. As I was telling you before, this is TypeScript code, so we need to compile this to JavaScript. So the JavaScript code is actually the one that is going to run in the blockchain. So what it is telling me right now is, yeah, I'm installing your smart contract. In this case, I have just 2 nodes, so it's installing on each node of the blockchain, and it is calling what it's called an instantiate function. The instantiate is telling the smart contract is ready to be used. So with this command, it may take actually a few seconds because this is actually downloading some things from the dependencies that I have. So let's give it a second. So while we are on this, if we remember the presentation to see the early comments that we had in here, there you go. We already run curl new, which is the one that created the blockchain for me. We are running right now curl install, which was the cc start command that I ran. If you're not familiar with JavaScript, these are like shortcuts for some common codes, right? I usually run this pretty commonly, so I create this function. in which it is saying it's going to package the code. The package is the compilation from TypeScript to JavaScript, and it is going to install the smart contract, and the function that is called install is going to run curl install node. So it's telling install a new chain code with this parameter. In this case, the parameter was car, which is the name of the chain code, the smart contract, and then node, which is the language. Hyperledger runs JavaScript natively, so you are not like working on our layer. You are working with Hyperledger still. The main difference was on the developer experience. So yeah, it's downloading some dependencies here, and it's through my cell phone, so maybe really slow right now. So yeah, any question in the meantime? Wait, these notes that you can see that probably we have to wrap up. No questions right now? Okay, so other things that you can do just to finish before we actually wrap up is that you can do things like invocations. You usually don't call the smart contracts from a console, right? You usually have an application that is calling them. But if you want to test things, we also have these commands that are called invoke. In this case, you can just do curl invoke the agreement, which agreement is the name of the smart contract, that in this case is car. And the C is the constructor. The constructor is the parameters that you are passing to the smart contract. So you can do anything in here, right? For example, I want to show you just a quick sample of a post in which you can get more details about these commands. Wow, the internet is actually working. This is our Medium. It's Medium/WorldSibu. In here, I'm showing how to use curly to work with non-convector smart contracts, right? As I was telling you, convector is a layer of smart contracts, but you can also, for Fabric, use Node, or you can use Golang. If you want to stick to Go, but want this development environment, you can still do. Actually, this example is using this default project of Golang smart contracts to install them. So here we're making a lot of tasks installing Go and Node smart contracts. So you can get more details in there if you wanna get started. So yeah, I don't think this is gonna work because we're downloading. Oh no, there you go. Now we have a smart contract working right here for us. And how can we know that it's actually running for us? We can start making invocation tasks. So I can do something like, for example, I can do, as you remember from the source code, we have this init ledger function. Just let me show you this so that you can actually see the full demo. We have this function that is called init ledger. This is just a testing function. It shouldn't be on production, right? But it is going to create mock data for me. So if I come in here and I call curl invoke the smart contract, you may have a lot of smart contracts installed. And the parameters, I'm going to tell this call the init ledger function. So it's going to make the call and it's going to tell me, okay, successful. Now you have data on the blockchain. So I can come in here and I can make another call. In this case, I want to check if this is actually working. So I can come in here and call query all, the query all function. So I just come in here and I say query all. And there you go. This is the JSON version of the data. Everything was serialized for me, so if I'm working in Java or C# or anything else, I can work with this JSON, and I can start modifying things. Just one last task, for example, I have another function in here that is called change owner. So I can come in here and I can say, let's see this JSON. This JSON has these properties. In this case, it says that it has this car with ID number 1, in which the owner is Tomoko. This is mock data. But I'm going to transfer this to me, so I can call this function that is called change owner in here in the bottom, and I will tell change the owner of the first one with this registry. Let me see. I put something wrong here. Oh, sorry. I missed the smart contract name. Like this, and there you go. Now I have invoked and I have got this, and I come here and I query all the data. Now I can see that this first car, now the owner of this car is Walter, which was the key that I included in here. And just now to wrap up, finally, as you can see, the goal of this is for people to build easier. to actually start without going through this big learning process. We have developers, again, from all the parts of the world using the tools. They are doing things like health record systems. They are doing things like supply chain systems as well. And when we talk to them, it usually takes them around 1 hour to just build everything and deploy and start testing things instead of all the months that usually took them to go through all the learning curves that this technology has. And I think this is important for the blockchain technology to be actually adopted, because people still wonder what are the actual use cases of blockchain in the enterprise. And one of the reasons for that is because we need experimentation to know the use cases for blockchain. We cannot just create theory out of nothing and say, yeah, that's going to solve everything and that's it. No, you have to go, you have to build, you have to make mistakes, you have to correct. But if this takes you 2 years to start investigating or exploring this uses, nobody's going to adopt the blockchain technology. And making things easier and less expensive is, I believe, something that is going to help the general adoption of blockchain. Thank you very much.